Recall from Monday that our general goal was to learn about a confidence interval. From the activity we were working on, we created a distribution such that when we split it up into pieces, we would have it so that 1% of the data fell above a specific point and 1% of the data fell below a specific point. In doing this, then, that created an interval such that 98% of the data should have fallen between 2 points. Now, this was when we knew the population mean value was going to be mu. Now, in general, we're not going to know what the population value is going to be. We're just going to get to calculate one statistic from the distribution. So, for example, we might have calculated a statistic that fell here on the number line. Or we could have calculated a statistic that fell here on the number line. In general, we have a 98% chance of getting a statistic that falls between the two lines that I've drawn here, or the red statistic type option. And we only have a 2% chance of getting a statistic that falls outside of the lines, either above like this blue one did, or it could be below as well. Now, the intervals that we have been working with are dependent on us knowing the value of the mean to determine how wide this guy should be. But if I take that same width and move it over so that it's now centered around my red statistic, that width will then encompass the true mean value. However, if I create a width of equivalent value around the blue statistic, then my width is not going to encompass the true mean value. So in general, statistics that would fall between the ranges of the lower bound and the upper bound that we had for our sampling distribution should then, when moved over and centered around our statistic, should encompass the mean, the true mean for the population. But if the statistic fell outside of the range like the blue one did, then when we shift the range over, the true mean value will not fall within that space.